The emu is a bird defined not by what it lacks, but by what it has refined to near perfection. Flightless, yes, but far from limited. Across the vast and often unforgiving landscapes of Australia, the emu has evolved into a creature built for endurance, awareness, and survival through movement rather than escape. It is a bird that does not rise above its environment, but moves endlessly through it, shaped by distance, heat, drought, and unpredictability. Standing close to 2 meters tall, the emu is the second largest living bird on Earth. Its height gives it a commanding presence, yet its survival strategy is grounded in restraint rather than dominance. The long neck acts as a living periscope above grasses and scrub, scanning for threats across open terrain. The small head, equipped with sharp vision, constantly reads the landscape, detecting motion rather than detail. In a land where danger often arrives quietly and water disappears without warning, awareness is life. The emu belongs to the ratite group of birds, a lineage that includes ostriches, rheas, cassowaries, and kiwis. These birds share a common evolutionary path, one that traded flight for strength, size, and efficiency on land. Millions of years ago, as Australia drifted into isolation, the ancestors of the emu adapted to a continent with few large mammalian predators but extreme environmental pressures. Over time, wings shrank, legs strengthened, and bodies rebalanced. What emerged was not a failed flyer, but a highly specialized terrestrial runner. The emu's wings, though small and seemingly insignificant, still serve a purpose. Covered in coarse feathers and tipped with a claw-like structure, they assist with balance during high-speed movement and help regulate body temperature. In hot conditions, emus may slightly spread their wings to release heat, while in cooler moments they tuck them tightly against the body. Every structure on the emu reflects efficiency, nothing ornamental, nothing wasted. Its legs are the core of its identity. Thick, muscular, and shock-absorbing, they allow the emu to reach speeds of up to 50 km per hour and maintain a steady pace over long distances. Unlike sprint predators that rely on short bursts of power, the emu is built for sustained travel. Each stride conserves energy, allowing it to cover enormous distances in search of food and water. Tendons act like springs, storing and releasing energy with every step, reducing fatigue in a land where stopping can be dangerous. Feathers play a surprisingly critical role in the emu's survival. Unlike the smooth, aerodynamic feathers of flying birds, emu feathers are loose, double-shafted, and shaggy. This unusual structure traps air close to the skin, creating insulation against both heat and cold. In Australia's climate, where temperatures can swing dramatically between scorching days and cold nights, this adaptability is essential. The feathers also deflect sunlight, reducing heat absorption and preventing overheating during long treks. Dietary flexibility further defines the emu's resilience. Emus are omnivores, feeding on a wide range of plant material including seeds, fruits, grasses, and leaves, as well as insects and small animals when available. This broad diet allows them to survive periods of scarcity when specific food sources vanish. They are not selective feeders, they eat what the land offers at any given moment. This opportunism is not randomness, but strategy. As they move, emus perform a crucial ecological function, seed dispersal. Many plant seeds pass through the emu's digestive system intact, often scarified in a way that improves germination. By depositing these seeds across large distances in nutrient-rich droppings, emus help regenerate vegetation and maintain plant diversity. In this way, their constant movement actively shapes the landscape, linking distant ecosystems through invisible biological threads. Water governs much of the emu's behavior. Though capable of surviving long periods without drinking, emus are highly responsive to rainfall patterns. They are nomadic, not by instinct alone, but by necessity. When rains arrive, triggering plant growth and insect activity, emus follow. Their movements can appear sudden and massive, with large groups forming seemingly overnight as individuals converge on newly productive areas. When conditions deteriorate, they move on just as quickly. Socially, emus exist in a fluid state. They are neither strictly solitary nor permanently social. Outside the breeding season, they may form loose groups, particularly during migration toward food-rich regions. These groups lack rigid hierarchies and dissolve easily when resources thin. Communication between emus is subtle yet effective, relying on deep, resonant drumming sounds produced by an inflatable throat pouch. These low-frequency calls can travel long distances, allowing emus to signal presence or maintain spacing without drawing excessive attention. Breeding season marks a dramatic shift in emu behavior and reveals one of the most extraordinary reproductive strategies in the bird world. Courtship is brief and understated. Once mating occurs, the female lays a clutch of large, dark green eggs, each weighing up to 1 kilogram. These eggs are among the largest of any bird species, both in absolute size and relative to body mass. After laying, the female leaves. From this point forward, the male becomes the sole guardian of the nest. For approximately 8 weeks, he incubates the eggs without eating, drinking very little, and losing up to a third of his body weight. During this time, he rarely leaves the nest, rotating the eggs and defending them aggressively if threatened. This period is a test of endurance that few animals could survive, yet it is a defining feature of emu biology. When the chicks hatch, the male's role intensifies rather than ends. Emu chicks are born with striking cream and brown stripes that provide camouflage in grassland environments. For months, the male leads them across the landscape, teaching them what to eat, when to freeze, and how to avoid predators. He remains vigilant, positioning himself between danger and his offspring, using intimidation rather than attack to deter threats. Predators remain a constant pressure, particularly for eggs and young chicks. Dingoes, large birds of prey, and monitor lizards pose serious risks. Human activity has added new dangers, including vehicle collisions and habitat fragmentation. Despite these challenges, emus have shown remarkable adaptability, often navigating agricultural lands and altered environments with cautious intelligence. Culturally, the emu holds deep significance in Australia. Featured on the national coat of arms alongside the kangaroo, the emu symbolizes forward movement, an animal that cannot easily walk backward. This symbolism reflects biology as much as metaphor. The emu's anatomy makes retreat inefficient. Survival depends on moving forward, adjusting course rather than reversing direction. From an evolutionary standpoint, the emu represents a successful alternative path. While many birds conquered the skies, the emu conquered distance. It proves that losing flight is not a failure, but a specialization, one that, in the right environment, offers greater long-term stability than aerial escape. The emu's story is one of quiet dominance through persistence. It does not overwhelm its environment, nor does it retreat from it. Instead, it moves through it endlessly, shaped by drought, rain, and time. Its survival is not dramatic, but it is profound, a reminder that endurance, when perfected, can rival any other evolutionary advantage. The relationship between emus and their environment has never been static. For tens of thousands of years, this bird has existed alongside changing climates, shifting vegetation zones, and evolving predator pressures. What distinguishes the emu from many large animals is not resistance to change, but responsiveness to it. The emu does not attempt to dominate its surroundings, instead, it reads them. Rainfall patterns, temperature shifts, and plant cycles all become signals that guide its movement. In this way, the emu functions less like a territorial animal and more like a living current, flowing across the continent in response to environmental rhythms. Historically, indigenous Australian cultures understood this dynamic relationship deeply. Emus appear prominently in Aboriginal stories, rock art, and songlines, often symbolizing movement, survival, and connection to land cycles. These narratives did not portray the emu as a resource to be extracted endlessly, but as a participant in a shared ecological system. Hunting practices were seasonal and respectful, aligned with breeding cycles and population stability. This long coexistence shaped a balance that modern systems still struggle to replicate. European settlement introduced a radically different relationship. As agriculture expanded, emus found themselves navigating fences, roads, and cleared land. Initially, this led to conflict. Emus feeding on crops were seen as pests rather than ecological agents. The most infamous example of this misunderstanding was the so-called Emu War of the 1930s, when attempts to control emu populations with military force ended in failure. The episode, often retold humorously, revealed a deeper truth. The emu's adaptability, intelligence, and mobility made it remarkably resilient to human attempts at domination. Over time, emus adjusted to altered landscapes with cautious pragmatism. Agricultural fields provided new food sources, while cleared land allowed for easier long-distance travel. Yet this adaptation came at a cost. Vehicle collisions became a major cause of emu mortality, particularly during periods of migration triggered by rainfall. Fences fragmented traditional movement routes, sometimes trapping emus in areas with dwindling resources. Despite this, populations remained relatively stable compared to many other large animals, a testament to the emu's capacity to adjust without losing its core survival strategies. Physiologically, the emu's endurance extends beyond muscle and bone. Its respiratory system is highly efficient, allowing for sustained oxygen intake during prolonged exertion. Combined with a slow, steady heart rate optimized for endurance rather than bursts of power, this system supports long-distance travel with minimal fatigue. Even the emu's digestive system reflects efficiency, extracting maximum nutritional value from low-quality food sources and conserving water whenever possible. Climate change now presents a challenge unlike any the emu has faced before. Rising temperatures, prolonged droughts, and increasingly unpredictable rainfall patterns disrupt the environmental cues emus rely on. In some regions, food availability becomes concentrated in shorter windows, forcing emus to travel farther and faster to survive. In others, extreme heat pushes the limits of even their advanced thermoregulation systems. These pressures do not immediately threaten extinction, but they reshape behavior, movement patterns, and reproductive success. Emus respond to heat not through panic but through strategy. During extreme temperatures, they reduce activity during peak daylight hours, seeking shade and conserving energy. Their feathers, already adapted for insulation, also protect against solar radiation. At night, when temperatures drop, activity resumes. This flexible schedule allows emus to survive conditions that would overwhelm less adaptable species. Yet flexibility has limits. If environmental changes accelerate beyond the emu's capacity to adjust, even endurance may no longer be enough. Reproduction remains a critical bottleneck in this equation. The male's extended fasting during incubation is only possible if he enters the breeding season with sufficient fat reserves. In years of poor food availability, fewer males can sustain this investment, leading to reduced hatchling numbers. This makes emu populations particularly sensitive to long-term environmental degradation rather than short-term fluctuations. Stability, not abundance, is the key to their success. Ecologically, the emu's continued presence acts as a stabilizing force. By dispersing seeds across wide areas, emus help maintain plant diversity and facilitate regeneration after fires or droughts. In landscapes increasingly shaped by extreme weather events, this role becomes even more important. Where emus disappear, regeneration slows, and ecosystems lose one of their most effective long-distance dispersal agents. Modern conservation efforts recognize the importance of preserving movement corridors rather than isolated habitats. For emus, survival depends not on protected zones alone, but on the ability to move freely between them. Wildlife crossings, fence modifications, and road planning increasingly take emu migration routes into account. These measures do not control the emu, they accommodate it, acknowledging that endurance requires space. The emu's intelligence is often underestimated because it does not manifest in tool use or problem-solving displays familiar to humans. Instead, its intelligence is ecological. It remembers water sources, recognizes recurring danger zones, and adjusts behavior based on experience. Emus learn. Individuals that survive harsh seasons carry that knowledge forward, shaping the behavior of future generations through both genetics and learned patterns. In a broader evolutionary context, the emu stands as proof that success is not always measured by dominance or complexity. Its brain is not large relative to body size, yet its survival strategies are precise. Its social structure is loose, yet effective. Its body is simple in outline, yet refined in function. Every aspect of the emu reflects a balance struck over millions of years between energy use, environmental unpredictability, and survival. As the modern world accelerates, the emu remains a reminder of a slower, more deliberate rhythm. It does not rush toward abundance nor flee scarcity in panic. It moves when it must, rests when it can, and invests deeply in the next generation when conditions allow. This rhythm, once aligned perfectly with the Australian continent, is now being tested. The future of the emu will depend not on its ability to evolve rapidly, but on humanity's willingness to preserve the conditions that allow endurance to matter. Pace, movement, and ecological continuity are not luxuries for this bird, they are necessities. Protecting the emu means protecting the idea that survival through balance still has a place in a rapidly changing world. In the end, the emu is not merely a flightless bird. It is a living testament to the power of endurance shaped by time. Where others escape upward, the emu moves forward. Where others specialize narrowly, the emu remains adaptable. And in a landscape defined by extremes, it continues to walk, run, and endure, quietly carrying the story of Australia across the land, step by deliberate step.